Ladies and gentlemen, welcome back to another live stream. So in this live stream, I'm gonna try to make a logic circuit simulator in Bevy game engine using egui. Of course, using Rust programming language. So this is gonna be just an experiment. I'm not sure if I'm gonna be able to do this, but we'll see. Though I'm pretty confident we can probably make a very good UI using egui for that, so I guess we'll just have to find out. Hello Loop Luminary, welcome back to the live stream. How is it going, man? Everyone, live of today is a bit late, but hopefully we could do enough today. So yeah, all right. Perfect. So let's start a new project and let's get going. So I'm gonna be using this library right here for the graph. I'm gonna be using egui snarl, and I was kinda, like surprised that there's no tutorial out there about this library. It's a pretty good library actually. Let me show you a demo that they have here. There we go. Look at that. So like they have this, and basically you could do stuff like that. So this is using that library, right? And so like you have that, and then let's say you have an expression or whatever. I'm not sure how this is supposed to work. And you got a sync. I'm not sure how this is supposed to work, but there is another demo that is nicer, which is by another guy, Attack Goat, which is for Node GUI. Look at that. So you have a purlin, multiply by a checkerboard, you get this. And I guess maybe we could do something else. I don't know, maybe another simplex, and then maybe what about a max operation? I don't know. Let's get the source here and the source there. And this is what we got apparently. But yeah, you got the point. So this is the library that we're hopefully going to be using. So yeah, let's keep going. Alright, so of course let's set up Bevy first of all. Let's set up a new project. So cargo new. And what should I call this? I don't know, Codotaku logic apparently. Okay, it's already full. Interesting. Well, let's go back, make their stream projects, I guess. Okay, stream projects. Now let's say cargo new, Codotaku logic, and let's just run VS Code there. And let's keep going. It's gonna take some time to actually compile this stuff, but yeah. Alright, so first of all, I'd like to always stop the server Rust analyzer so it doesn't interfere, because it really just sucks. So alright, so first thing first, I want to switch the tool chain to nightly. So channel, tool chain here. Tool chain, channel equal to nightly. That's first thing. The other thing is .config slash, .cargo slash .config.toml. And I'm gonna go here to my own repo real quick. My repositories. And I'm gonna go to Codotaku Bevy template, and then I'm just gonna copy this config toml. So we're gonna basically be changing the linker, though you have to install it using you have to install rust-lld using cargo. So yeah, just keep that in mind, because basically it's faster in linking essentially. So the other thing that we're gonna need other than that is let's see, let's go to cargo toml here and see. So of course dynamic linking. So I'm gonna say cargo add bevy dash dash. Can I say version? I'm not sure. Anyways, we're gonna say dash dash no default features dash dash feature. Oopsies, what the heck? Dash dash features. We're gonna only include the bevy render, bevy assets. So, and is there anything else we want to include? Probably also multi-threading. And I think that's basically it. Maybe enabled features. Disabled and recognized multi-threading. Okay, that's interesting. Let's go to cargo toml here. And apparently didn't add it. Okay, fine, just say that. And then we should have bevy without any default features. So basically we're only gonna enable the bevy systems that we're actually gonna be using. So the other thing that I talked about is multi-threaded, right? So, and we also want to add Bevy EGY. Let me make sure the name is correct. Also, let's add this log. So we disable logging, like so it's gonna be faster basically. And yeah, Bevy EGY, there we go. And for Bevy, I'm just gonna use 0.14.0. Because it's the most compatible with other plugins like Bevy EGY. And yeah, I think that's basically it for the, yeah. Other than that, yeah, I think I'm good for now. So cargo built, and let's just wait for this to build. Other than that, I'm gonna actually right now start the server too, and we should be good to go. Alrighty. Oh, I haven't added Bevy snarl yet, actually. So yeah, let's add Bevy snarl too. Well, not Bevy snarl, EGY snarl, yeah. And this is it basically, EGY dash snarl. Well, let's cargo add EGY dash snarl dash dash no default features. I don't think it does. Yeah, I only have EGY probe inserted, which we are not going to be using for now. So yeah, now let's just make sure to build this, and let's go. This is going to take a bit of a while, though. It's going to take way less than if you just included the whole Bevy crate, like instead of just, you know, disabling default features and then including the ones that you need only. So yeah, this is basically for rendering. I'm also gonna be needing Bevy winit, I believe. Probably, yeah. My bad. Bevy winit for the windowing. Otherwise, if you don't have a window, nothing would work. Well, there we go. Let's go with app new dot run. Well, first of all, the add insert plugins, I think. How do you add plugins again? What the heck? Add plugins, yeah. And let's go with default plugins, basically. And honestly, instead of doing this, we could just say prelude. There we go. Dot run. Da, da, da. I could have prepared this off stream, but I wanted to show the new setup that I came up with, anyways, which seems to be fine for me for now. I could have also made Bevy compile in release mode, so it's faster. But honestly, I don't want to slow it down. So yeah. Anyways, let's see right now how we could. So we're gonna need to add the plugin for EGY. So Bevy EGY, and for that it's called EGY plugin, like that. All right, perfect. And then we're gonna need a system that would run every frame, because well, EGY is an immediate mode UI. solutions. So add systems, yeah. And here we're gonna run this in update. I'm gonna call this UI. Now fn UI. I don't remember. I think egui contexts. If I remember well, it's still like indexing the whole thing, basically. Is it true? Is it correct? Let's see. Come on, dude. Oh boy. Or we could just simply go to egui, Bevy egui create, and check out the example real quick. The example. There we go, examples. Is the stream fine, by the way? Please let me know. There's no dropped frames apparently, which is nice. So, well. Yeah, egui contexts, mutable contexts. Egui, well. egui contexts. That seems about right. Contexts. Right. Now let's just make sure to actually, hey Chambles, welcome to the live stream. Thanks for letting me know that the stream is running fine. Alright, so we got the contexts here. And what should we do next? I think we need to get the context out of it, right? So context mute, right? Yeah. Apparently, and I think that would give us the context, ctx. Yeah, there we go. Now we could basically do, oops, we could check out the example here. Let's just take this code, copy it or steal it, and let's go import this. Let's see if this works by any chance. Alright, so we got the context. Oh boy, nah, just say this. And this should work. Okay, let's compile this and run it. Did I add dynamic linking for Bevy? No, I haven't. Damn. Well, I probably should. Let me close the window, please. There we go. Alright, so alright, let's see if this works first of all. It's taking a while. Alright, there we go. And here we go. It works. Perfect. Perfect, perfect. Now, the only problem with this kind of solution is that you would always get an error when you close the application that was called for an initialized context primary window. Make sure your system is run after init context. This is because the UI function, it's ran in a compute task pool, right? So it's in parallel, and it basically is not, at least it seems like it's not guaranteed to stop execution before the window gets destroyed, basically. So what happens here is that this function, when it gets executed, doesn't find the window at the end of the application when you try to close it, basically, and that errors. So the solution is very simple. What we're gonna say is just if let some context is equal to context dot get try context mute. There we go, and there we go. Interestingly, the AI generated this code. Let's see, what is that? Central panel probably would just take the whole, yeah, exactly, covers the remainder of the screen. That's perfect. I should though add that dynamic linking feature, and there we go. Perfect. Let's add that dynamic linking. Hopefully it wouldn't take that long to recompile. Dynamic, my bad, I forgot it. Dynamic linking. Let's see. And also something that I would note about this setup with dynamic linking and this Rust LD thing is that sometimes what would happen is that you would get some weird linker errors and you would be forced to clean up your whole project and like restart the whole compilation from scratch. But fortunately, someone shared with me a solution in Discord, which just saved my life, honestly, because otherwise I would like recompile the whole thing from scratch once again. Let me see if I can actually reproduce that. I'm not sure if I can reproduce that. Let me see if I can. I don't know, whichever. I just want to change the code, then run this, and then basically interrupt it. Let's see right now if it works. Oops, hold on. Let me do some valid code, I guess. Print line hello world, and let's try to interrupt this and see if that works. Apparently I couldn't reproduce it right now. Maybe print line is not that much of a change. But basically how would you do that? Like, how would you fix that? You just say cargo clean. Now the problem, if you just say cargo clean, you're gonna clean the whole project and you have to recompile the whole thing, which is not needed, right? You only wanna clean your package, like your own application, not the dependencies, basically, and that would fix it. So you'd say -- package, and then you would say the name of your package here, which is in this case Codotaku logic, right? You would just clean that, and as you can see, it only cleaned my own application binary. And then you could just run again, and it would only recompile your own application, not the whole thing, you know, which is great. Okay, perfect. Now let's go into egui snarl stuff, and this is gonna be quite interesting. Well, here we go. Did I add it already or not? Yes, I did. Perfect. So let's go to the examples repository. Examples, demo rs. Which version we're using? 0.5, but there's no 0.5 here apparently, which is interesting. But anyway, it doesn't matter, at least for now. So, all right, let's see what we're gonna do here. Show. I should change this mouse. Okay, let's see what we got here. They're installing some image loaders here. We're not gonna need that. And here, snarl. Yeah. So let's first of all start by making a resource that would hold the state of our graph, right? So we're gonna derive default comma resource and struct. What should I call this? I guess graph maybe. And then here we're gonna have the state of the graph, which is basically gonna be the snarl graph thing. So as you can see, snarl is a generic node graph container. It holds graph states, position nodes, and wires between their pins. It can be rendered using snarl shell. And here, as you can see, I have like a T generic, which is not bound by anything. And that's basically gonna be your own graph data, as you're gonna see in a second. So for now though, yeah, let's make a node struct, right? And then we could basically make use of it here. There we go. Now we need the setup system here real quick. Add system setup, well, startup, right? Startup schedule, and we're gonna call it setup. There we go. Of course, the names doesn't really matter, but that's kind of like the conventions there. But anyways, so here we're gonna need mutable commands. There we go. And now we're just going to say graph default. We're not going to add any nodes for now. Please just insert the resource commands. Oopsies, insert resource graph. And there we go. Perfect. We don't need, I think, mutables for now. And these unused crap would be annoying. So what I could do, I could just say allow unused must use. Sorry, unused, allow unused, and deny unused must use. There you go. Also dead code, really. It's just very annoying, though you probably want to incomment that when you want to commit to see if you have anything that is unnecessary. Anyways, so now we have the graph state. Perfect. What are we gonna do next? We have to show it, right? Now to be able to show this, so we're gonna need first of all to get it here. Yeah, exactly. Mute graph, rest mute graph. So here we basically get the resource, access to the resource graph mutably. And now we need to say graph.state.show. Now here you're gonna need a viewer and the style, snarl style, ID salt, and the UI. Now for the ID salt, I'm not exactly sure what this is, but for now this would work. Just say any string there. And here the UI, of course, is just passed from here, from egui. The style, now I would actually store this style instead of creating every frame, but it kind of sucks because it doesn't include send. Like if you basically say, you can't basically put it in a resource. You have to put it in a non-send resource and so on. So for now, I'm not gonna really bother. I'm just gonna create a new one and pass it in. So I'm just gonna say snarl style default, and there we go. Now for the viewer, this is the important part, or should I say the interesting part. So here we're gonna say struct. Let's see how they did it here. What should I call this? Viewer. Yeah, so they're calling it demo viewer apparently. Let's call this graph viewer, I think. Right, so it's gonna be an empty struct really. It's just used to implement the actual snarl viewer trait on it, basically. So snarl viewer node for graph viewer. There we go. Now let's just implement the missing members and let's go. As simple as that. Here, now we could basically just say, I think, graph viewer like this. Yeah, exactly. You don't need to construct it because, well, it doesn't contain any fields, so that's great. It's just kind of like a holder for the trait here. All right, perfect. Perfecto. Now, if I actually try to run this, it would work, I think. Let's see. There we go. So right now we got this grid that we could use to navigate our graph, which is perfect. Now, what's next? Let's see. Now you can notice that this is to-dos, but it didn't crash because these didn't run at all because we don't have any nodes. So let's try to add some node here. So mutable graph, and let's just say graph.state.add, well, node. How do you add a node? Let's insert node. There we go. And here you give it basically position 2, right? So pause 2, and let's just say default, and then here, oh yeah, and here you construct here the generic that you have passed. In this case, currently the generic doesn't contain anything, so you could just do that, right? Cargo R now, and we should have one but of course it would crash, right? Because it have hit these stuff, because right now it tried to basically render this node right here, and then of course it to know how to render it, it would need to call these functions, but then of course these functions we haven't implemented them just yet. For now, let's just hard code this to node, let's say, right? And for the outputs, this is how much outputs this particular node that you have here have. Let's just hard code this for now as 1 and inputs as 1, just to make this work. And now, or we could just say 0, and if we say 0, we don't have to actually code these ones. We could just keep it as to do for now. And let's see if that works. And there you go. Right now we actually have a node, but it doesn't have any inputs or outputs. So let's actually include these. And so now we have to actually implement this. So for now, we could just say pin info default. Pin info basically contains things like what is the shape of the pin that you want for this particular node, what is the size of it, what is the fill color, the outline, stroke, and the style of the wire connected. Perfect. So for now, I'm just saying default. Nothing interesting there. Now let's say cargo R, and we should have a node with one output pin and another input pin. Perfect. Now I just shown you how you can create a node, but now we actually need the user to be able to create new nodes himself, right? So to choose, let's say, an AND node or an input node, output node, etc. So how are we going to do that? Well, so that's where the node generic comes in. Let's see, it's going to store the state. So instead of struct, we don't want a struct actually, we want an enum, right? So enum node. Now this would contain input basically. And for the input, we're just going to have a boolean, it's just, either there's electricity or there's no electricity essentially. Same thing with the output for now. Well, at least for now, we're going to keep it this simple. Dead simple. And here, NAND gate. So for the NAND gate, that's going to be interesting. We probably want a node. So I'm going to say box node, common node. Might be a no question, but curious. Why enum over struct? Enum because I want to be able to represent multiple states, right? So like it's either an input, an output, or a NAND gate, right? So a node, like a graph node, is either an input, output, or a NAND gate. So that's why I want an enum instead of a struct here. Okay, so here we need to box this, of course, because otherwise this node wouldn't have a finite size. So like if I actually don't include this, and this wouldn't work, because it would say recursive type node has infinite size, because it cannot compute the size of this. Because like if you come to think about it here, the node is inside of it a node, and then inside of it a node, etc. But when you say a box, here instead of storing a node, you just store the address to a node, right? And basically this you just like store it in the heap, right? So there is an allocation there. Now most of you would actually do it like this, right? Like this. But I think it's just a, one less allocation doing it like this, right? So yeah. All right, cool. So let's see if this works out. We don't need this anymore because we're not going to be programmatically adding nodes. We're going to give the user a menu to add nodes. And how are we going to do that? Well, apparently there is a function in this trait that actually can help us with that easily, so we don't have to do the work ourselves, at least not all the work. But yeah. All right, so how are we gonna do this? Let's see. Well, first of all, let's actually do this title stuff and so on. So let's see the AI There we go, perfect. Input, output, NAND. Though I think I could probably find some crate that can like, you know, from like automatically deduce a name string from the enum itself using reflection. But anyways, let's just keep it simple for now. For the outputs, yeah, all of them would have a 1, true. For the inputs, I don't think all of them too. Let's try a match on this. So no, the input, oh yeah. Actually, let's match on this too, my bad. So we're gonna match on the node, and then if it's an input node, then we have 1 output, right? And if it's an output node, then it have 0 outputs. If it's a NAND gate, then it have 1 output, which makes total sense. Inputs. So the inputs, if it's an input node, then it have 0 inputs. If it's an output, then it have 1 input. If it's a NAND gate, then it have 2 inputs. And there we go, perfect. Now to show input, I'm not gonna change that for now. It's fine like that. Now the next thing, as I said, is we need somehow to do a graph. So there is a has graph menu in this trait that we can implement, and then we could basically say true to enable it, right? Because by default it's actually implemented as false, right? And now here we could actually implement another function after that, which is show graph menu. Now be careful to make sure to implement this and set it to true, otherwise this wouldn't be ran, right? Now show graph menu. Right now we can construct our menus in egui, pretty much. So how are we gonna do this? Let's see if the AI's suggestion works here or not. So this seems fine. We're just making a button, right? If it's clicked, then we're adding a node, input node, in this case output here. NAND gate, it seems to have some little bit of trouble for some reason. Let's see why that's the case. So apparently I have a missing brace here, I would guess. And no method add node found for mutable reference mute snarl node. Yeah, because it's called insert node. Insert node. Well, meh. So we already got the position that the user is trying to put it in, so that's great. And by default, we're gonna be setting it to false. Now let's see if we can regenerate this one, and let's see if we can regenerate this one too. There we go. All right, perfect. Perfect. And honestly, we should probably have, like, let's say an unknown, because basically, well, unknown is basically false, yeah. So that's fine, maybe. All right, so let's go cargo R, I think, and see if this works. And though, yeah, I've actually forgot about something, but let me show you. So if I actually right now right click, then I have this menu that we just created. But if I click, it doesn't, like, the menu doesn't go away. So to actually fix that, we have to make sure to say UI.close menu, right? So every time we do this. Now you may think to actually remove this from here and just do it here, but no, that's not gonna work, because we only want to close the menu if one of these are clicked, not every frame, because otherwise that would be every frame, because this code actually runs every frame, because like egui renders everything from scratch every single frame. But anyways, so this should work now. So right now we could actually put an input, put an output, and put a NAND gate. There we go. And we could, let's say, have another input here, and then there we go. Then we could link them together, and yeah, let's go. Nice, perfect. Let's say we could have another NAND gate. Oopsies, let's remove that. Maybe put it, I don't know, here. And we have a triple NAND gate, I guess. There we go. Anyways, you got the point, right? So it actually works perfect. Now what we want to like to add is the input should be toggleable by the user. So it should have like a checkbox here, right? So how are we going to do that? is by making the node having a body, right? So has body. So, and here we're gonna match on the node. If it's an input, then it should have a body. Output for now, yeah, should have it too, why not? NAND gate, not really, I don't need it for now. Now let's go with show body. Okay, match snarl, get node. So basically here what we're doing, we're using snarl that we get here as a parameter, and then get node, and then we give it the node ID, because this node that we get here is just the node ID, not the node itself, right? So we're getting the actual node itself here, and apparently that doesn't work because get node is actually an option, because this node ID could not exist by the time this function get ran. So then what we could do is to simply hold on, if let sum, exactly, let's see, if let sum node, right, equal to snarl.get node match node. Now if it's an input, we want to add a checkbox in the body. Now the checkbox is interesting. So the checkbox, what it takes a checked mutable boolean, right? And then a text. So here input we do have a boolean apparently, which is a value basically, right? And so we could too simply say mutable value, right? And here some sort of text, which we don't need, though this should be get node mutable, so we can get a mutable access to the value. Right, he cannot borrow value as mutable. That's strange. Try removing, oh, I see, because this is already mutable, I see. So let's remove that, please. The output, same exact thing, though unfortunately I didn't find a way to actually like make this not toggleable by the user, but you know, just show the checkbox just for rendering essentially, but whatever, it's fine. Node NAND gate. So the NAND gate would give us two things, two nodes here, and in fact here in show body we don't really need that, in fact, yeah, because it's not going to be reachable anyways, in fact, because we set it to false here, so that's fine. Alrighty, perfect. In reachable, NAND node should not have bodies. Okay, perfect. And now if we actually cargo R here, we should have an input, and there you go, we have a checkbox that we could actually pick. Now let's start by implementing a very simple logic here of hopefully having, like, you know, when this input gets checked, the output also gets checked. So we start simple basically. This is the part that I don't know if I can manage to implement, honestly. The UI part, as you can see, it's not that hard using the library, which is amazing. But let's see if we can implement this. Alright, where do we even start? So I think we would start at the output, right? So like, and then we would kind of backtrack from there maybe. Let's see, show. Now, like, ideally we would have, like, let's say some sort of a tick system. UI checkbox, output value. Let me think about it. Input, output, node. So this is a slab of node T. Node of the graph wires. Because the thing is, here you cannot do it like regularly how we would do it, because like let's say you have you're parsing an expression. What you're gonna do is you're too simply gonna walk the whole tree, right? And that's not gonna work here, because like you can have multiple outputs, right? So like multiple graphs in the same thing, right? So it's not one whole entity. That's the problem here. And I'm suffocating already. Okay, let's see. UI add button node has body, show body. So this is the value that we need. Well, maybe let's start by making a tick system, and then let's see what we could do from there. So of course we're gonna have access to the graph here, and we need some way to make like a timer. And I actually never done this before using Bevy. So let's find out Bevy timer. And let's see, rest time. No. If config.timer.finished. Interesting. Okay, I think we're gonna use this then. So we create a new resource. So this is gonna be our tick timer. Oops. Or simulation tick. We could call it simulation tick, I don't know. Whatever. And here we're gonna grab that. So apparently we need the rest time too. Interesting. And then we take the timer, config.time .tick time.delta. Tick.timer .tick time.delta, and then if tick.timer.finished, then here we need to do the actual tick logic, right? So yeah, let's just do a print line for now and see if that works. But of course we have to set up the simulation tick here. Insert resource, simulation tick, and then insert resource. Perfect. True. Mismatch types expected timer mode. Found boolean. Timer mode, of course, repeating. And yeah, that's probably it. Insert that resource, and then we should be good to go. And 1 second is probably too much. Let's maybe say for now 0.1 second. Not too slow and not too fast. And why there's no... Oh yeah, I forgot. We gotta add the system here too. So add system as well. Update, comma, tick. And let's go ahead and... Or we could also do it this way. UI comma tick, just like that. Now we should have that happens. Perfect. So cool. Now we need to freaking figure out how this would work. Da, da, da. Let's see what kind of functions we have here. So here we got this nodes iterator apparently, and also nodes mutable. Nodes mutable and iterate pause. Also iterate through node IDs. Da, da, da. Let's start maybe by finding the output node, I guess. So for node in graph dot state dot nodes da, da, da. Maybe nodes mutable. Okay, so we have mutable access right now. Now basically we're gonna match on a node. Now if it's an output or an input, then apparently do nothing, I guess. Mismatch types, expected struct, box node found tuple. Huh. Okay, apparently there's no way around that then. Interesting. So I guess I'm just gonna call this inputs then, and then let A be. There we go, perfect. Now let A is equal to match A input. And node output equal to match A and NB. This is what the AI generated apparently, which is interesting. But what about the output? So this is basically updating the NAND gate. Node output, not A. That's interesting. Now, how about updating the outputs exactly? Well, actually we need to probably reiterate maybe. Yeah, I think so. And here we got value. Now the thing is, the value, what should it be? Nah, dude. We need to get the pin, the input pin, and figure that out. Essentially. How are we gonna do that? Well, the problem here, we have nodes. We don't have access to the graph. Checkbox. Yikes. Let's see what's gonna happen here if I print that. Output false. Output true, okay. Well, in fact, let's just do this, right? But of course, if we do this, it doesn't work. But if I have a NAND gate, what happened there? What the heck? The NAND gate just like transformed into an output. That's interesting. Nah. Yikes. That's surely not what we want. So let's, instead of doing this, we should probably get the node IDs instead. Maybe. Node IDs. Mutable. I don't think I need mutable access to the IDs themselves. Oh, it actually gives mutable access to the node. I see. That's cool. Now, nope. No thanks. Let's see. So here we get the ID and then the node. Now I guess we could use the ID to get the pins and so on, maybe. So like, let's start by, yeah, let's actually break down this a bit. Let's just start by finding all the output nodes too simply. And I don't actually need mutability for this, really. IDs, node IDs. Data, what is that? But what's the difference between this and the other? Dude. Oh, there's no other. What? Well, anyways, fine. So here, let's have let outputs is equal to a vec. Let's say, and match. Well, if matches node, then outputs dot push ID too simply. Now here mismatch types expected node. EGUI star less similar names. What? That's very strange. Then let's just try to match on this directly. Node output, please. Honestly, I don't care about that. Just say output stop push ID. Now apparently it's not liking that for some reason. Oh. You have a value t, a position, and an open. I see. But if I want only the IDs, can I get that? That seems about right. Perfect. And I'm just gonna ignore all the others for now, I think. Okay, perfect. Cannot mutate that. Now we found kind of like the sinks, and we gotta figure out how to do the next step. So basically I need the input pin. How can I get that? The in pin returns input pin of the node. Then apparently here I need to give it an input ID. Let's pin. So here it needs the node ID. Or basically node, too simply. Then here I could say node. And here input. Well, output node only have one input anyways, so we could just say 0 here, yeah. And that's, we get an in pin. And what that in pin gives me, it gives me remotes. Can I dbj pin.remotes, please? As you can see, pin.remotes, nothing. Now if I add an input, now I have that, which is cool. Now there's another thing that I could actually do, which is this too. At that point it's kind of like an OR gate. So in some sense I have to evaluate all of these and OR them together. Interesting. But for now, just hard code this. So how are we gonna do this? So as you can see, it actually gives us the node ID of that output pin ID. And then the pin, which is in this case output 0. Interesting. So I guess that result, let's say, is equal to, I don't know, false maybe. Now for remote in pin.remotes, let's just like ignore NAND gates for now. Let's just focus on input nodes for a second and see how this would work out. So remote is an output pin ID. Does that work? Is that how it's supposed to be? Yeah, so that gives me an output pin ID, and then I get the actual output pin, which is great. And now what that gives me, that gives me the remotes again. And it gives me the ID output pin. So I don't really need that, honestly. I don't need access to the remotes, I think. Yeah, there's no need. I just need the value right now of the actual input thing, right? So let's get the if let's yeah, this gives me a node ID. So let's say if let's node, or honestly just unwrap that really. Let's keep it simple. So let remote node is equal to graph.cget node unwrap. Perfect. So now we're getting a node. Now if that remote node is a input value, missing match arm output int NAND are covered. For now, we're just gonna say in implemented, right? Or let's say to do. Okay, here input. How are we gonna do this? So I think what I'm thinking is or equal to value, I think. But of course, since it's an OR, should probably be true here. And maybe that's basically the case. Of course, this still not the whole thing, but let's go step by step. Try to figure this out. So we got an output and we got an input. Now if we link this together, and oh well, we actually calculated the result, but we didn't apply it though. So that's true. That's true. Get node. Well, I know the node would be, but anyways, whatever. This is unreachable too simply. And let's see if this works. If this goes as expected, then we should at least have. Nah, it doesn't work. Interestingly. Actually, it does make sense, my bad. Should be false by default. My bad. Now if I have output here, have an input connected. Hooray, it works. Perfect. So now we have that. And if we have multiple inputs connected, it should be like an OR gate essentially. Right? So if one of these are on, then it's on. If both are on, then it's also on. So that's perfect. At least we got this one working. Right? So that's perfect. Now we need to figure out the rest. And then we need to kind of figure out a pattern, recursive pattern, to evaluate the whole thing, right? So yeah. Node input. So if we have a node NAND gate. Let's see what it's gonna do here. Well, of course, here we got values. And kind of surprised that there's no destruction for boxes, but anyways. Or maybe there is, but I just don't know. Like, what about a ref AB or something like that? No? Nah, doesn't seem like it. I don't know. Anyways, so this works. AB. Match A, and we check if A is an input. Then we get the value. Match B. That's pretty interesting. That's pretty sick. Alright, let's see if this works. Of course, this is still not recursive. But let's just test this first of all. Let's have an output, of course. I'm gonna have two inputs, and we have an NAND gate. Then, well, it's on by default, which makes sense, right? Perfect. Because it's a NAND, it's not an AND, it's an AND, yeah. Now let's connect these inputs here. The answer should probably also have, let's say, maybe some sort of a body here, which like you don't have to. Man, let's just keep it generic like this, I think. Does that make sense? I don't think so. So if both of them are on, they should be off. But it's not. Which is interesting. Why that's the case. Good question. I mean, this seems about right to me. Well, let's do some debugging, I guess. Oh boy, no. I'm gonna probably make it years, or you know, fine, whatever. Add input, two inputs real quick, and add an output, and add an NAND gate. Boom. Boom. Well. So A and B are both false. If I set A to true, it doesn't seem to work. Well, I think we probably want to do that, you know, input pin thing yet again. Yeah, I mean, what you're doing here, in fact. Walaikum salam, OG Garen. Welcome to the live stream. Oh my god. This is wild. Honestly, I think an NAND gate should probably just have like a boolean, because here we're not having like a regular tree structure, you know, we're having a graph, right? So this should probably just be like the boolean output, right, of this, essentially. Yeah, exactly. And the actual inputs is defined by the pins. Yippee. Yippee. Interesting stuff. I guess we're gonna have a lot of fun here. Oh boy. I guess I asked for that. Let's see if the AI could help us here by any chance. Meh, why not? No, what the heck? Not really. The thing here right now, I'm matching on the remote node. Now here I need to get the input pin again. Yeah, I need to get the input pins. So if it's input, we're fine. But if it's a NAND gate, it's more interesting than that. Input 0. So this is kind of like A. And let B is input 1. But remote.node. Oh boy. So what this gives us again? It gives us an N pin. And what an N pin contains? A list of output pins. Do I actually want that? What exactly do I want here though? Like for real. Oh boy. I guess I basically want to get the remotes of those input pins. Right? Yeah, and then this is kind of recursive after that, kinda. How we're gonna do this? So where this is coming from? Yeah, this comes from every output, right? So how are we gonna do this? Probably you want this whole thing. Well, now we're only gonna have one output. Well, basically up to here, I think. Probably. So let's just try to make a function here real quick and see if we can figure this out by any chance. Graph, mutable, graph. Node egui snarl node ID. Whoopsies. Oops. Port node ID. Well, what the heck? By egui. Okay, cool. So I think at the end of the day, you kind of should like give a boolean true. And then here we basically want to return a result, I think. And then basically if you have an input, then you're done. No need for recursion. Otherwise, oh. Okay, I think I'm seeing what's happening here. we probably, instead of node ID here, we probably want input in pin, right? So in pin, maybe in pin ID, I would guess. Right, and then to simply, do we really want to get the in pin itself? I don't think that's a good idea. I don't know. But either way, here we got the in pin. So in pin ID, perfect. Now here, instead of this, you want to essentially say F and then give it the in pin. And same thing here recursively. Oh boy, that's super beautiful, but I'm not sure if it's gonna work. But I mean, it makes sense in my head. I don't know if this would work. I've never done this in my life before. It's like, because this is really hurting my brain, because like I was assuming that maybe I'm gonna do it like, you know, parsing regular trees, expressions and so on. But this is not like any regular tree. This is an actual graph, which is interesting. But anyways, we're gonna find out, I guess. Pretty much. So that's pretty sick. And even, well, nah, input is a terminal thing, so that's fine. Yeah. Yeah. I mean, that makes sense in my head. And I think you can't have an output, correct? Yeah, you can't have an output there, I think. So unreachable. Alrighty, dude, that's pretty sick stuff. Alright, now the real question is, would this actually work? Or am I just tripping here? Very good question. Brother asked a very good question. Let's see. For remote in pin, remotes. So we're actually doing that here. Perfect. Alright, so we're gonna basically remove this whole thing. ODS. Yeah, I guess we're just gonna have to find out. Let's see. Oh man, please work. Please work. Add output. So, if we have one input, oh, oopsies. Oh, what the heck? If we have one input, it works. Perfect. If you have two inputs, it also works. Perfect. Now, what if we have a NAND gate? Now this is the real deal. So true. Perfect. Now if I have two inputs here, and I toggle both. Oh man, that seems to work. Oh my god. Now the real deal is, what if we have another NAND gate here? So like we would have three NAND gates, kind of. Okay, three-way NAND gate. And I haven't really implemented this kind of behavior yet. So right now I just have to do it like this. And there we go. So if, like, basically, if just... Okay, so if none of them is on, then apparently it seems they got an output. Oh, my bad. Well, I think NAND gates are probably not really done this way. Like, not, you know, what is it even called? Anyways, let's just remove this, please. Oh shit, how do I remove this? I have no clue. Well, let's try to make a NOT gate, okay? A NOT gate is actually pretty simple. You just do it this way. Hopefully nothing would crash here. Okay, so we made the NOT gate. Let's go, dude. It works. Oh my god. That's crazy. Okay. What about a NAND gate now? So a NAND gate would essentially be 2 NANDs, right? So we're gonna need 2 NANDs here. So this would kind of like be like this. Oh, what the heck I'm talking about? No. Well, basically like this. Right? And then you would have this and this. So this should be an AND gate. So like this is basically a NOT gate, since the output here goes in both inputs. And this should be, this whole thing should be an AND gate. So, and it is. Alright, it freaking works, man. Really. Crazy. Crazy, crazy. Now we need to figure out a way probably to do some abstraction. You know, like to be able to create new nodes, user nodes, somehow. I have no clue how the heck, where to even start with that, dude. Oh boy. But what about like a 3-way AND gate? So this is how you make an AND gate. So we could just create another 2 NAND gates, essentially. Yeah, just like, well, what the heck? Just like this. Like this. Oh. What? So this is an AND gate. Oh, we're gonna need 3 AND gates then. Yeah. NAND gateception. Okay, let's see. Well, again, this should go in both places. And so basically you would have this here. And you would grab these 2 here. And you would have this. What in the world is this? Oh no, that's not really. No, we want this here, right? And then basically we want. Oh shit, I'm very confused right now. So here we got an AND gate. The first input comes in. And so the output of this should go here. Huh. Then I guess we don't want. Yeah, probably. My bad. So we probably don't need this AND gate right here. And like you basically go like this, I guess. And then like that. Now this is supposed to be a 3-way AND gate. Like 3 inputs AND gate. Without these are just like orphan nodes essentially. So yeah. And yeah, it works. Perfect. Love that. And yeah, we basically did it. Right now we're just gonna add the abstraction, but right now you could indeed use this to make some crazy stuff. Now, one interesting thing would be to allow for these output and input nodes to have multiple of these, like to have multiple bits essentially. So like instead of having to create multiple input nodes, you would have one input node with a lot of inputs and so on. But honestly, I think I'm gonna probably end the stream here for now, so it's not gonna be too long. Yeah, so yeah, pretty much 1 hour and a half and we made it. There we go. So using an NAND gate, you can pretty much make anything else. We could add indeed these things ourselves, like we could add built-in AND gates and OR gates, but well, where's the fun in that? And yeah, thank you guys all for coming in. Thank you for Loop Luminary as always. Thanks for Chambles for coming in for the first time. Thanks for WoGG Gearing as always. So thank you all for tuning in, and see you in the next one. Goodbye everyone. You're probably gonna, I may actually publish this in GitHub, so stay tuned for that. And see you later. Goodbye everyone.